Hi there, grade 12s. I would like to work through some examples that we couldn't get to in these videos so that you're on top of it. You have a chance of being on top of it. So we're going to apply the principle of conservation of momentum. And some of these also use the principle of conservation of kinetic energy during inelastic collisions. Our first example says a car mass 600 kilograms travels west at a constant 28 meters per second. It collides into the back of car B, mass 900 kilograms, traveling in the same direction at 16 meters per second. After the collision, car B moves west at 24 meters per second. Ignore the effects of friction and calculate the velocity of car A immediately after the friction. Them saying ignore the effects of friction means it's an isolated system. And we use the principle of conservation of momentum. It's always, I enjoy drawing diagrams to show the situation. So we've got car A that is moving to the west and its initial velocity is 28 meters per second and its mass is 600 kilograms. Car B is also going towards the west and A hits into the back of B. B has a mass of 900 kgs and it was moving. Initial velocity of B is 16 meters per second. Right, so mass of A times initial velocity of A plus the mass of B times initial velocity of B would be the mass of A times the final velocity of A plus the mass of B times the final velocity of B. Mass of A is 600 times the 28 and 900 times the 16. Mass of A is 600. We don't know the final velocity of A. Mass of B is 900. Final velocity west is 24 meters per second. So let's do the calculation. It's 600 times 28 plus 900 times 16, and then I need to subtract the 900 times 24, and we get 9,600, which must be divided by 600. So we get B if A is 16 meters per second, and the fact that it's a positive 16 means that it's going west. Right. Because all the motion is to the west, everything is taken as the positive direction of motion. In the second example of video 1, a 1 kg trolley and a 2 kg trolley are connected with a compressed spring. The trolleys are held stationary before they are released. After the explosion, the first trolley has a velocity of 5 meters per second to the left, while the second trolley has a velocity of 2.5 meters per second to the right. Show that momentum is conserved during the explosion. So we can't assume that momentum is conserved. So first have to calculate the total initial momentum. Now, because everything was stationary, the initial momentum is 0 kilograms meters per second because the object was stationary initially. So we need to calculate the final momentum. So it's the mass of 1 times the final velocity of 1 plus the mass of 2 times the final velocity of 2. In this case, the two objects, one after the explosion moves to the left and the other one will move to the right. You need to choose your positive direction. I'm going to choose to the left as the positive direction and to the right as my negative direction. Mass of 1 is 1. The final velocity of 1 is 5. Plus the mass of 2 is 2, and its final velocity is negative 2.5. This brings us to 5 minus 5, which gives us 0 kilograms meters per second. And because the total final momentum is equal to the total initial momentum, momentum is conserved. It is always important to answer the original question. Show that momentum is conserved. And because they say show that the momentum is conserved, you can't assume that they are equal. So you can't start off with the total initial momentum equals the total final momentum. You need to calculate them separately first and then conclude. This brings us to the end of video 1 on the conservation of momentum. Thank you for watching the video.